Hey guys, my name is Talia. I'm a staff member at Discovery and I'm going to help you do your homework today. So your professors love Taylor Swift. I bet you didn't know that. That's sarcasm. Anyway, and basically you do a survey on the quad asking a bunch of people whether or not they listen to Taylor Swift and whether or not they like Taylor Swift or they're a fan. That's how it's termed here. And we're given some initial probabilities shown here, and it's organized in a table, but I just wrote it out like this. And then you are asked to find the probability that somebody listens to Taylor Swift, given that they're not a fan of Taylor Swift. Kind of a weird combo there, like why would you listen to Taylor Swift if you're not a fan, but that maybe will indicate that the probability is kind of low, so keep that in mind when you get your answer. And the terminology of the question, where they say stuff like 64% of people are fans given that they listen, and also in the little answer box it shows P of listen given with the line not a fan. Those things should both indicate to you that this is a classic Bayes rule question. So exciting. Alright, so in the question they give you the probability that if somebody listens to Taylor Swift, the probability that somebody listens to Taylor Swift is 0.46 or 46%. And then they give this to you, but also it's just the complement. The probability that they don't listen to Taylor Swift is 0.54, which makes sense because you add up to 1. They also say that the probability that somebody is a fan, given that they listen to Taylor Swift, is 0.64. And the probability that somebody is a fan when they don't listen to Taylor Swift is 0.11. So we have these probabilities, and now we need to find the probability that somebody listens to Taylor Swift given they're not a fan. And then we can structure this with the classic Bayes rule formula, which I will put over here. P of A given B times P of A, getting ahead of myself. P of A given B equals P of B given A times the probability of A divided by the probability of B. And then B and A can just be, mapped to the first or second events, whatever you're tasked with here. And so if we restructure this with this formula, we'd say that the answer is the probability that they're not a fan, given that they listen, times the probabilities that they listen, divided by the probability that they're not a fan. Alright, and we have, we don't directly have all of these, right? We have this one, P listen is just 0.46, but we may have to do some thinking and some math to find the other two. So let's start with the easy one. The probability that they're not a fan given they listen. And so, in this case, whether you're a fan of Taylor Swift or not can be considered like a binary event, like you're either a fan or you're not. And so in terms of probability, the probability that you're not a fan is the complement of the probability that you're a fan. So based on that logic, we can say that this term here, the probability that you're not a fan given that you listen, is just the complement of this one. And so the way, I'm going to go a little bit deeper with this, the way complements work with conditional probability is that the complement is always applied to the first term, right? Because in this case, let's say we know that the probability that you're a fan given that you listen. So we know the probability that you're a fan given that you listen is 0.64. And then we apply the complement, so probably that you're a fan, the complement of this given that you listen. You can see here the complement is applied to this first term because in this case we're just comparing like these two things, hold the probability. We're already considering that this is true, that like this person already listens to Taylor Swift. So we don't put the complement here because that's not what we're looking for. We know that they listen to Taylor Swift. So we apply the complement here, and then the complement of being a fan is just the probability of not being a fan. And this is like a bunch of extra steps. You don't have to write this out every time. I'm just kind of explaining it because it's something that people could get tripped up on during their listen. Is 1 minus 0.64 equals 0.36. So we can plug that in here. So we know so far we have 0.36 times probability of listen is 0.46. Again, this is just 1 minus this. And then this is the last part we need, the probability that someone's not a fan. And this we'll have to use the law of total probability. And I go pretty in depth on the law of total probability in another video, the one about the jurors question with people that are guilty or acquitted. So if you really need like a more in-depth explanation for that, I would go watch that video. It's the same concept and everything. But for now, I'm just going to kind of briefly talk about it and then go through the formula. So again, in this case, we know that there are certain people who are not fans, right? There are people who listen to Taylor Swift and are not fans, and that's like these compliments here. And then we know that there are people who don't listen to Taylor Swift and they're not fans. So let's just write out those probabilities just to have them available. So this one we found earlier, probability that not fan given listen equals 0.36, and then probability of not fan given don't listen is 0.89. So those are the two types of people that aren't fans. And we don't have an overall probability that somebody is not a fan. That's not given to us. So we have to calculate it with the law of total probability. Like in these two different conditions, where people are not fans, how do we put those together to find the overall probability that somebody generally is not a fan? I can't imagine not being a fan of Taylor Swift, but that's besides the point. So the formula for law of total probability is, I'll write this in green to distinguish it. In this case, probability that someone is not a fan equals probability of not being a fan given that you listen times the probability that you listen in the first place plus the probability that you're not a fan given you don't listen times the probability that you don't listen in the first place. And these things we either were given or, calculate with the complements that I just talked about. And we can just put these 4 different probabilities in and find this total probability. And in this case, not a fan, given that you listen, is 0.36 times the probability that you listen overall is 0.46 plus the probability that you're not a fan, given that you don't listen, 0.89 times the probability that you don't listen, which is 0.54, and then this result is like 0.6462 or some, I don't remember if I rounded this or not, but yeah, it's roughly 0.6462, and now you can plug that in for your denominator. And you have everything you need, and then you can just put this in a calculator and spit out a number, and you get, what do you get? 0.36 times 0.46 divided by 0.6462. It's like a super long decimal. You're gonna have to round it into some fashion. 0.256267, blah, blah, blah. Roughly 0.256. And that's your answer. So this requires a little bit of thinking about complements and how complements are applied to conditional probability. Remember, complements apply to the first term, because this is what we're attaching the probability to. This is the event that has probability, is the first one. And then our Bayes-Rule formula would log total probability for an overall event that we're not given, and then plugging everything in. And yeah, that's the solution.